Hi, folks. I decided to do one more IXL today. This one is going to be two-step linear inequalities, and I'm going to go ahead and solve them. So we're looking at K.8, which is solving two-step linear inequalities. Now, inequalities are solved almost identically to how we solve equations. In fact, I'm going to go through the exact same steps that I would go through if this was an equation. There is one weird rule that you absolutely must follow every time, and it is true for this particular one. So this one says negative 1c minus 7 is greater than 3. And if this was an equation, negative 1c minus 7 equals 3, we would add 7 to both sides. And I would be left with negative 1c is equal to 10. This one, I'm adding 7 to both sides. And there is an addition property of inequality, just like there's an addition property of equality. And I end up with negative 1c is greater than 10. And in equations, I would divide by negative 1 on both sides, and everything's fine. C is equal to negative 10, and I'm done. Unfortunately, there is a special rule for inequalities that when you divide or multiply by a negative, you're changing the sign. And that changes the sense of any inequality. And there's a really simple way to understand it. For example, if I said that 2 is greater than negative 5, everyone can see 2 is certainly greater than negative 5. But look what happens when I divide both sides by negative 1. I get negative 2 on the left, and I get positive 5 on the right. Notice that I divided by negative 1, just like I did in the inequality here. What happened was I changed the negative to a positive, and I changed the positive to a negative, and that changed the sense of my inequality. This is always true. Whenever you change the sign of both sides, you have to change the sign of the inequality. So we have C is less than negative 10. And from now on, I'll just follow the rule. In this one, I'm going to go ahead and write it negative 4q minus 1 is greater than negative 9. I'm going to add 1 to both sides. I'm not going to show all the steps every time, but adding 1 doesn't change anything. That is negative 8. I added 1 to both sides. And I'm going to divide by negative 4. Now that is going to change the sense of my inequality. Q is now going to be less than 2. Now, one of the ways that you can test to see if it's actually true is I could choose a value that is less than 2, like 0 or 1 or negative 1 or negative 2, and see if it actually works in my inequality. And I can see that it does. But just to give you an example, negative 4q minus 1, it says, is greater than negative 9. That was my original inequality. Well, if I choose a solution from this set, if I pick q is less than 2, let's say q is negative 1, and I put negative 1 instead of q. That's positive 4 minus 1, which is 3, and that is certainly greater than negative 9. So we can see that at least one solution works for the solution set, and I know it's correct. It's q is less than 2. For the rest, I'll just go through and solve them for you. We have negative 8 minus 5h is greater than or equal to 2. We're going to add 8 to both sides. We get negative 5h is greater than or equal to 10. We're going to divide by -5, which is going to change the sense of the inequality, and it's also going to change the sign. It's going to be -2. I just divided by -5 on both sides. This says that h could be less than or equal to -2. That's what this little symbol down here means, that it could be equal. In this one, we're going to subtract 10 from both sides, and we're going to get 3k is greater than or equal to, you know what? I want to show you something. 3k plus 10 is greater than or equal to 1. And when I subtract 10, a lot of students look at this and they're very concerned, because notice that I had a +1 and I end up with a -9, and they think, well, I changed the sign. The thing is, you didn't. Look, the 3k is still +3k. This side, we subtracted 10 from both sides. You never change the sign when you subtract or add. You only change the sign when you multiply or divide by a negative, when you change the sign on both sides. I'm going to divide by +3, which again does not change the sense of my inequality. K needs to be greater than or equal to -3. Again, a real easy way to check this is to pick a big number that's bigger than -3, like 10, and put it into your equation, and you get 40 is greater than or equal to 1, which is true. So K is greater than or equal to -3. I'm going to subtract 9 from both sides, and then I'm going to divide by 10, and I'm going to get u is greater than -1. If you want to work it out, please do. This one's a little different. This is a good one. I want to show you something. A lot of people get confused as to what to do because the A is on the wrong side. Lots of choices. Probably the easiest way to deal with this is to add A to both sides. That's going to be by far and away your easiest way to deal with this. So I'm going to have A plus 5. Remember, when you add or subtract, you never change the sign. And then I'm almost done. I need to subtract 5 from both sides, and I get A is greater than 1. And you can check it. If I pick a number greater than 1, like 2 or 3 or 4, and I put it in here, it's true that 5 will be bigger than that. So A is greater than 1. Again, I'm going to add B to both sides, and I'm going to have B minus 4 is less than -6. All I did was add B to both sides, and then I'm going to add 4 to both sides. And that gives me B is less than -2. And we don't want to spend a lot of time on this one. I'm going to add V to both sides, so that I have V plus 7 is less than 4. I'm going to subtract 7 from both sides. I'm going to get V is less than -3. I'm going to add D to both sides, so I get D minus 9 is greater than or equal to -10. There are other ways of dealing with this negative D, but it's a lot easier the way I'm doing it. I'm going to add 9 to both sides, and I'm done. D is greater than or equal to -1. Oh, we have an S over 6 this time. Okay, I like these. I'm gonna write it out for you. Now, I'm going to add 8 to both sides, so that's going to be easy. I'm just adding 8. It's going to eliminate this 8. Adding 8 to this side gives me 1. Now, I'm not going to divide by 6. I'm going to multiply by 6. I have to do the opposite to both sides. I'm not changing the sign. S is greater than or equal to 6, and I'm done. almost to the proficiency level. S over 2, I'm going to subtract 9 from both sides. And then I'm going to multiply by 2. And S is less than negative 6. Remember, you only change the sign when you multiply or divide by a negative. I'm going to go ahead and leave that one there. I could have added q to both sides, just like I've been doing, and get q is greater than 6. But I'm going to go ahead and leave it on the other side. So I'm going to show you what happens. People get a lot of confusion going here. So there's a lot of ways to get confused. First of all, the q is on the wrong side of the inequality. And a lot of people get confused as to what to do. If you change this inequality going the other way, it still has to point at the smaller number. And the 6 still has to be bigger. So if you change the sides, in other words, you switch these two, you have to switch the sign. Negative 1q plus 12 still has to be less than 6. And I'm going to read both of these. It says, reading it this direction says 6 is greater than, I'm going to point at it, 6 is greater than negative 1q plus 12. If I read it the other way, I get negative 1q plus 12 is less than 6. This one says negative 1q plus 12 is less than 6. It's the same thing. Just have to be careful. One way to think of it is that it still has to point at the same side. I'm going to subtract 12 from both sides. I'm going to get negative 1q is less than negative 6. Again, I just subtracted 12 from both sides. I'm going to divide by negative 1, and that's going to change my sign. And I'm going to get q is greater than 6. Notice that it was a lot easier to just simply add q and subtract the 6 from both sides. I get q is greater than 6, I believe. And yeah, that's what I get. Yep. Okay, I have a double negative in front of my 1f. So that means that it's really a positive f. So this really says negative 53 plus f is greater than or equal to negative 54. And you're going to have to add 53 to both sides. And there's a lot of ways to mess this one up. But anyway, it's f is greater than or equal to negative 1. You're done. This one we're going to add 2 to both sides, and I'm going to have 9 is greater than or equal to g over 2. I'm going to multiply by 2 on both sides, and I get 18 is greater than or equal to g. Now, it'll probably allow me to write it in this direction, but I'm not sure. I'm going to try it just to see if it lets me. But if you were going to write the g first, remember, you would still have to have it pointing at the g, because this specifically says g is less than or equal to 18. And the second one down here also says g is less than or equal to 18. It has to still be in the same direction. Comparative to the sides. Anyway, I'm going to try the 18 is, what was it? 18 is greater than or equal to g, isn't it? Let's see if it lets me do that. Yeah, it does. Figured it might. I'm going to add 1 to both sides, and then I'm going to multiply by 8. And I'm going to get y is less than 24. All I did was add 1 and multiply by 8 on both sides. There is no change because I wasn't multiplying or dividing by a negative. Almost done. I'm going to add my h. I'm going to have h plus, I added h to both sides. 88 is less than 30. Just seems like the easiest way to go. Subtract the 88, you get h is less than negative 58. And we're done. Oh, I like this one. I'm going to subtract the 51, and I'm going to get 3 is less than m over negative 16. I'm going to multiply by the negative 16, and that is going to change my sign. Be careful. It's going to give me negative 48. My sign changes because I multiplied by a negative. Very important that you change the sign. Now, a lot of people are just going to maybe leave it in there. I would prefer to write it this way. And I'm going to do this on occasion just to keep it in mind that it's the same. Both of these are equivalent, and it's very easy to get those wrong. So it's good practice to go with both of them, less than negative 48. All right, let's see what we got. I'm going to add the k and subtract 11. So I'm going to get 41. So I'm going to get k is less than 41. All I did was add k and subtract 11 from both sides. In this one, I'm going to add 24 to both sides. I'm going to get 6j is less than or equal to 36. I added 24 to both sides. I'm going to divide by 6. That's not going to change my sign. I'm going to get j is less than or equal to 6. And we're almost done. A few more, maybe 3 or 4. Oh, they wanted to give me some big ones. So I have z over negative 155. As soon as you see that division by a negative, you know I'm going to be ended up changing the sign. I'm going to subtract 885 from both sides, and I'm going to get less than or equal to 3. All I did was subtract 885 from both sides, and I'm left with 3. Now I'm going to have to multiply by negative 155, and don't forget, if you multiply or divide by a negative in an inequality, you have to change the sign. That is going to be 665? Let's see. No, that's not. That's negative 4. Really slow today, 65, I believe. I'm going to go ahead and do my multiplication on the side just to show you. 155 times 3. We have a 5, carry the 1. That's a 6, carry the 1. That's a 4, 65. And it is negative, and I did change my sign. Z is greater than or equal to negative 465. We're almost done. I'm going to subtract 789, which is going to give me W over negative 5 is greater than or equal to. When I subtract the 789, I'm going to write it. I'm going to get negative 3, and then I'm going to multiply by negative 5 on both sides, which is going to change the sign on both sides. Notice the negative is now positive W, and this is less than or equal to 15. And it's really easy to test a solution, but I'm done. W is less than or equal to 15. And we're almost done. I'm going to subtract 356 from both sides. And I have J over 117 is less than, looks like I'm getting a negative 6. Huh? No, a positive 6, excuse me. And then I'm going to multiply by 117 on both sides. There will be no sign changes going on here. There is no negative being multiplied. And that's going to be 702 maybe. That's 660 plus 42. That's what I did in my head, just so that you can kind of see what I'm doing. I multiplied, and basically how I did it was I said 6, and I did this in my head, and I did this in my head. I added the 660 plus the 42. Anyway, that is 702. And J, come on, J is less than 702. Yeah. And it looks like a few more. Darn, I'm getting tired of these. All right, so we have a 389. I'm going to add 389 to both sides. And I'm going to have 179u is greater than, and this one is going to be 716, I believe. And then I'm going to divide by 179. And I'm guessing it's going to go in there 4 times since, and it looks like it's 4. I'm just going to test it real quick. 179 times 4 is 6, carry the 3. That's 1, carry the 3. And that's 716, sure enough. And we get u is greater than 4. And it looks like 2 or 3 more. Dang. Okay, subtract 2 and you get b over 7.29. That looks scary, but the thing is that I just have a negative 1 on the other side. So when I multiply by the 7.29, I just get b is greater than or equal to negative 7.29. I multiplied by a positive 7.29 on both sides. Very common error is to see this negative and get confused. You are multiplying by a positive on both sides, so there's no sign change. B is greater than or equal to negative 7.2. Looks good. A couple more. I'm going to add 3. I get less than or equal to 7. And I'm going to divide by 1.4, which happens to be 5. F is less than or equal to 5. And 2 more. Add 1 to both sides. We get d over 4.73 is greater than 2. We're going to multiply by 4.73 on both sides, and we're going to get 9.46, and it looks like we're done. D is greater than 9.46. It is possible you make an error if you multiply in your head, but it's really good practice. Please do it, if at all possible. It's really good to practice your arithmetic. I'm going to add the 2.61. I have r over 2. When I add the 2.61, I'm going to have greater than or equal to 4.61. And then I'm going to multiply by 2 on both sides. I'll actually write it there for you. And again, practice working in your head. There's no change, sign change. That's going to be 9.22. And, practice a little bit. This is supposed to be an r, I think. Yeah. R is greater than or equal to 9.22. And it looks like we have one last one. V over 2. I get to do a little work on the side here. Okay, so I've got 6.5. It's my negative, actually. And I've got 2.84. Now, the signs are different, so I have to take the difference. And the way to do that is to write the bigger one on the top and subtract. So 4 from 10 is 6. I borrowed. And 8 from 14 is 6. And 2 from 5 is 3. And it is negative. This does not change the sign. It is negative 3.66. If I were still in high school and I was on my last problem, I would definitely grab a calculator just to check it. The way I'm going to check it is I'm just going to add it backwards. That's going to be 10, carry the 1. That's going to be 5, carry the 1. That's going to be 6. And I suspect that it's right. I'm going to multiply by 2 on both sides. And V is greater than or equal to negative 7.32. And it's looking good. I did not change the sign. V is greater than or equal to negative 7.32. Hopefully I didn't make an error. And we are done for the day. So good luck with those. I hope you all have as much fun as I did. I suspect not. Have a good day.